based on this voltage we will get all these other voltages. Means if the 3.3 volt always is missing, we cannot get all these voltages. So always when you get a failed motherboard or a dead motherboard, you should check whether you have this voltage or not. Also, another main voltage basically is plus 5 volt always. Also for plus 5 volt always, if this voltage is missing, we cannot get also these voltages. First step is to check whether the adapter generates 19 volt. The second step is to check the power jack or the DC jack. Is it good or not? Because when the DC jack is bad, is not connected to the motherboard, the 19 volt will not pass from the adapter to the motherboard circuit. After that, we have the power SRC. This basically is 19 volt. Okay, so we can get this voltage from the adapter here or from the battery. Okay, because we have two types of source. We can use adapter or battery. After the presence of 19 volt, we should automatically find plus 5 volt always and plus 3.3 volt always in the motherboard without powering on the laptop. The camera is bad. What is the problem? Where we can start? Very easy guys. This is where we can start. So let me remove all these circles and switch. We have here, as you can see, plus 3.3 volt is missing, means the camera will not work as the customers told us. So this is the path. This is the right path, guys, from here to the adapter. Here we have adapter. So we have the problem with the camera. We can make sure if the camera itself is good or not by changing it with another camera. This is the first step. We can do it or not, no problem. Then we should check, of course, this IC. This is a control. Is this control generate this 3.3 volt? No, it doesn't generate 3.3 volt. So we should go back and look for the source or the IC that feed this IC. This is the IC. This is the responsible here. Okay, this IC is the IC that is, of course, that control this IC. So we should check, for example, this one. We didn't get here plus 3.3 volt for this IC. Means this IC is bad? No, we should check the input. The input here should be 3.3 volts. So hi again, so welcome everyone to another power sequence, but this time for Dell Latitude, because the two power sequences that we have seen before is basically for HP laptops, okay, but this time is for Dell Latitude, exactly for Dell Latitude 5480 5488, okay, laptop. So here basically we're gonna see also the power sequence and the voltages within a Dell laptop motherboard. Basically the working principle is always the same. You can find just a slight differences between each laptop, but always the working principle is the same. Here please, we're gonna focus of course, we're gonna discuss and study this power sequence, and also we're gonna focus on two voltages. Here, as you can see, the first voltage is 3.3 volt, as you can see, always, and the second voltage is, as you can see here, plus 5 volt always. Do you see? Please pay attention here, okay? So, do you see this voltage? The plus 3.3 volt always, based on this voltage we will get all these other voltages. Okay, means If the 3.3 volt always is missing, we cannot get all these voltages, including voltage for the LAN, for the wireless LAN, for the PCH, for 3.3 volt RAM for the processor, okay, for also WWEN, for LCD VDD, for the memory, etc. Means this is one of the most important voltage in the motherboard. So always when you get a failed motherboard or a dead motherboard, you should check whether you have this voltage or not. Also, another main voltage basically is plus 5 volt always. Also for plus 5 volt always, if this voltage is missing, we cannot get also these voltages, as you can see for many basically peripherals in the motherboard, including, for example, the VCC for input output for the SIO. We have 1 volt for prime core, we have plus 5 volt RAM, we have for USB, as you can see, basically USB connectors, for audio, for the hard disk drive, and many other peripherals. So do you see? All these basically voltages here are developed or are extracted from these two voltages, plus 5 volt and plus 3.3 volt. That's why when you get the main any failed motherboard, especially when the motherboard has a power failure, the first thing to check, of course, is the adapter. Here we have the adapter. Is the adapter good? You should check if the adapter generates 19 volts, depending of course on the type of laptop. It could be 20 volt, 18 volt, 12 volt, etc. Let's assume the majority of laptops will find 19 volt. First step is to check whether the adapter generates 19 volt. The second step is to check the power jack or the DC jack. Is it good or not? Because when the DC jack is bad, is not connected to the motherboard, the 19 volt will not pass from the adapter to the motherboard circuit. Okay. After that, of course, we have the power SRC. This basically is 19 volt. Okay. So we can get this voltage from the adapter. Okay, we can get it from the adapter, from the adapter here, or from the battery. Okay, because we have two types of source. We can use adapter or battery. And of course here we have, this is the charger or the charge IC. We have charger, its reference is ISL 88738. Okay, so this is the control IC. So we should get 19 volts. Check first the adapter, then check the power jack, then we should check whether we get 19 volts or not. After that, of course, after the presence of 19 volt, we should automatically find plus 5 volt always and plus 3.3 volt always in the motherboard without powering on the laptop. Okay, so this is why I want to manifest for you the importance for these two voltages that we consider main voltages. So we have three main voltages in the motherboard. The first is 19 volt, the second is 3.3 volt, and the third is 5 volt. Based on these three voltages, all voltages, as you can see, are developed based on these three voltages. The main voltage 19 volt generates these two voltages, 5 volt and 3.3 volt always. And based on this, we get all these voltages for the motherboards. Okay? Here, basically, we have ICs. Those squares, as you can see, are controllers. So do you feel a little bit that you understand what is happening inside the motherboard? It's easy, you know, the motherboard, you can troubleshoot it and find the problem. Do you remember when I told you before in the previous videos that I can detect any failure in any motherboard regardless of the difficulty or the persistence of the failure within any motherboard? I can detect the failure in just 1 minute, maximum 2 minutes. The motherboard is repaired. And more than that, for the short circuit, I have a long experience and expertise in the short circuits. So basically I can detect the short circuits in just 10 seconds max. 10 seconds max I will spot the short circuit problem. I have many videos on my YouTube channel. You can just go to the home page and under the video section write short circuit or detect short circuit, and then you will see all videos about how to detect short circuit. Okay, so what is basically the secret? The hidden secret is understanding the power sequence. Easy. We have adapter, we have battery, we have 19 volts, and we have controllers. These controllers, in order to generate this voltage, all these controllers have to receive the main voltage and enable signals. So without receiving, for example, I find, for example, that let's assume plus 3.3 volt always is missing. Means what? What is the problem? Is it the control IC? No. I should first verify within verify if this IC receive the 19 volt. If the 19 volt is missing, so of course it will not generate plus 3.3 volt. I should go back and check the charger or the control IC or the charge IC. Is it good or not? Check the adapter first. Is the adapter generate 19 volt or not? Check also the DC jack or the power jack. Is it good? Is it soldered correctly to the motherboard? Is 19 volt pass first? Is the MOSFET? Because always we find a switch. So between the adapter and of course generating 19 volt, we have always a switch. We should also check that switch or MOSFET, is it good or not? Okay, it's easy. Just understand the power sequence and how voltages are divided and managed into the motherboard. For example, we have a problem. Let's assume, for example, that, please pay attention, here we will generate or create a failure, a live failure. Okay, let's assume, guys, that for example a customer bring you this laptop. For example, it told you that the cam or the webcam, the camera is not working. So in terms of troubleshooting a hardware problem, we should look for the camera. Where is the camera? Here, as you can see, we have the camera over here. Do you see? We have cam. Okay, so after checking the cam connector, we didn't find, for example, plus 3.3 volt. Okay, we didn't find plus 3.3 volt. So what is the camera is bad? What is the problem? Where we can start? Very easy, guys. This is where we can start. So let me remove all these circles and switch. We have here, as you can see, plus 3.3 volt is missing, means the camera will not work as the customers told us. So this is the path. This is the right path, guys. Here we have the right path. So let's again change this arrow to, for example, another color, the green color. For example, the green color means we will address and solve the problem. This is the path. from here to the adapter. Here we have adapter. So we have the problem with the camera. We can make sure if the camera itself is good or not by changing it with another camera. This is the first step. We can do it or not, no problem. Then we should check, of course, this IC. This is a controller. Is this controller generate this 3.3 volt? No, it doesn't generate 3.3 volt. So we should go back and look for the source or the IC that feed this IC. This is the IC. This is the responsible here. Okay, this IC is the IC that is, of course, that control this IC. So we should check, for example, this one. We didn't get here plus 3.3 volt for this IC. Means this IC is bad? No, we should check the input. The input here should be 3.3 volt. So we should check whether we have 3.3 volt or not. If we have here plus 3.3 volt, means this IC receive the red voltage. It should generate the plus 3 volt red. Okay, but we should check this enables signals also. This enable signals should be present. Okay, so let's assume that 3.3 volt is missing. We should go and check, of course, what? Check here the charge IC circuit, especially the DC jack and the adapter. Is the adapter deliver and generate 19 volt or not? And also, if we work or the laptop work the battery, we should check if the battery is good or not. Do you see? So without understanding the power sequence, this is just an example. Without understanding the power sequence, you can, for example, get like this type of error. You cannot know what is the problem, where can I start, etc. Okay, so guys, this is basically the structure. So let's remove again all this around. This is the structure. We can divide this power sequence into parts. We have always the source, the power, or the source or the input power. It could be from the adapter or the battery. Okay, of course, this is the charge circuit. And of course, we have the purpose of this charge circuit basically is to get this voltage, the main voltage, 19 volt. After that, this main voltage will be applied to all controllers in the motherboard. All these are controls. Also, those are controls. Those basically has as a purpose to generate other voltages, like the plus VCC core for the processor, the plus VCC basically for, this is GT, it also for chipsets. We have also here plus VCC SA, this is another voltage. This is basically a low voltage for other circuit. And we have basically here we have it could, this one power SRC, and we have of course another voltage. Basically here this is for peripheral devices. Okay, for peripheral devices, and all those are for CPU. By the way, here as you can see we have for example here some references, as you can see. So let me make it easy for you. Okay, good. So here as you can see, this color, basically we can see this is the orange color. We have CPU power. This color means it are for CPU, as you can see. This also is for CPU, and those also are for CPU and chipsets. This color, the pink color, we have PCH. PCH means the NOT bridge or the graphic card with the ICH, and this is the GT power. Of course, for chipsets and graphics. And this color, the blue color, like this one, this is basically for peripherals. So this is Bluetooth. This one is for Bluetooth. Okay, so this one is for Bluetooth, because we have peripheral device. This color also is type C power for connectors, and for GPU power, the green one, for example, for this one, the GPU graphic processing unit. Okay, so let's go back to the section. The first section is the source, where we have the adapter and the battery, the main power. Based on this power, we will get all these powers, but of course we have other main power is the plus 3.3 volt and 5 volt always. Then we have controllers. Okay, we have controllers, and then we will get powers. This is main powers, and over here we have secondary power. Okay, because all this power are based on this, especially plus 3.3 volt and plus 5 volts. So I hope that you understand a little bit, and of course I'm sure that you will understand the process and the working principle of the voltage and signal within the motherboard. And by understanding this approach, you can easily figure out, troubleshoot and repair, and of course fix 100% any motherboard you have. And make sure and be sure that if you follow me and you stay tuned, I'm sure that you will be professional, and you will be, of course, like me, you will figure out and fix the motherboard issues within minutes or even seconds. So please, if you find this video a good video, you enjoy it, please don't forget to like the video, because your likes really motivate me to create more and more and more videos for you. And of course, this kind of videos are unique and exclusive videos. Basically, there is not a lot of videos like this deep and unique videos. And of course, you deserve a lot, to give you a lot of information, and I'm here to assist you and to help you until you become a pro. So please like the video, share and subscribe, because if you don't subscribe, I cannot help you. I can only help you if you subscribe and of course hit the notification bell in order always to stay updated for future videos. And for anyone who want to join me in my Patreon page, you are very welcome. Of course, anyone who wants my WhatsApp number, you can join me in my Patreon page as a mentorship experience member, and you will get my WhatsApp number instantly, where you can ask me anything about how to repair laptops and computers. And of course, I can assist you step by step via WhatsApp if you have any motherboard issues until you fix it. Thank you very much, and see you with another video.